and we are going to be doing some examples over average velocity and instantaneous velocity. So I pulled this example directly from your textbook, section 2.1, number 9. I'm not going to pull it out in front of me, but if you want to take a minute to pull that out, you can. They give you this equation, negative 16t squared plus 96t plus 6, and it's about a ball being tossed and that kind of thing. So I went ahead and put units on it because I know a lot of you guys are used to seeing that, just so you can kind of see where things are coming from. This negative 16 is dealing with acceleration in feet per second per second. The 96 comes from the initial velocity of 96 feet per second. Don't forget this is a t. I put a little hook on my t's so I don't confuse them with my addition signs. And then this plus 6, this constant at the end, is the starting height at a time equal to 0. So I just went ahead and put those units on. In your AP Calc exam, when you actually go and take the test, they may ask you for units, but it'll be at the end. You won't have to carry them through like you have had to do in pre-calc. It's a good idea to check those things out to make sure that the units all do work out. But if they ask for units in your AP Calc exam, you can just tack them in at the end of the problem. So the first question asks for the average velocity during the first second or in the first second. So we want to start with 0 going up to a time of 1. So I need to figure out what h of 0 is and h of 1 from this equation. And you could use your calculator. Plug in 0, that one should be easy. You get a 6. Plug in 1 and you get an 86. So if I want to find the average velocity, remember that's going to be the slope between those 2 points, the beginning and the end. So I'm going to take the h at 1 second minus the h of 0 seconds over 1 second minus 0 seconds. So when I'm looking at this here, I can see this is the difference in my heights, my positions. Right, the height at 1 second minus the height of 0 seconds over the difference in the time. So I know that this is 86 feet minus 6 feet over 1 second, because 1 second minus 0 is just 1. And then I can go ahead and subtract these, and I'm going to end up with 80 feet per second. This right here is, again, the average velocity. This is the slope of the secant line connecting from an x value of 0, or I should say a t value of 0 to a t value of 1. So again, this is the slope of the secant line. So secant line slope. Now, the other question asks us for instantaneous velocity at 1 second. So some people have questions, especially as we start talking about velocity, speed, position, all these things. There's some helpful information up here in case you didn't have a chance to look at it. Velocity is used when direction is taken into account. Speed is used only when you are not concerned about the direction of travel. Speed is the magnitude of velocity. And basically, if velocity is greater than 0, it's positive. It means it's moving up or in the positive direction. Velocity is negative, means it's moving down or in the negative direction. So we'll do lots more with velocity and position and all of that stuff. But for the instantaneous velocity at 1 second, what I want to do is I want to find 2 points really close to 1. So I can find the average velocity from 0.9 to 1. So this is my interval. Those are 2 times, a time of 0.9 to a time of 1. We already know what h of 1 is, but we can plug in 0.9 and see what we get. So that's the first thing I'm going to do. I'm going to find that average velocity there with a point that's just on the other side, just I guess to the left of a time of 1. So h of 1 second minus h of 0.9 seconds. All of that divided by 1 second minus 0.9 seconds. And if I plug in 1 second, I know I get 86 feet. If I plug in 0.9, I'm going to get 79.44 feet. And then 1 second minus 0.9 seconds is 0.1 seconds. And then I can go ahead and divide those two numbers. subtract, and then divide, and I get 65.6 feet per second. And that's pretty close to the instantaneous velocity, but I'm going to do one on the other side of 1 as well. I'm going to go 0.1 away in the other direction. And then I'll have two different average velocities that then I could average those two together. So I'm kind of going a little bit to the left and finding that velocity. I'm going a little bit to the right, finding that velocity. And then I'm going to average those two numbers. So now I'm going to find the average velocity using the interval 1 to 1.1 this time. So I'm going just a tenth in the other direction now. Do something very similar. The height at 1.1 seconds minus the height at 1 second over 1.1 seconds minus 1 second. So when I'm looking at this, I know that I'm going to be finding the average velocity when a time is 1 and time is 1.1 seconds. So I can plug in this 1.1 is the one that I don't know. That's 92.24 feet. Minus 86 feet, I have already done that one, over still 0.1 seconds. And then I go ahead and calculate that. I get 62.4 feet per second. And neither one of these really is the instantaneous velocity. I'm close, but they are still slightly different. I'm going to go ahead and average these, and that will get me even closer to the instantaneous velocity. So if I average these, add them together, divide by 2, I get 64 feet per second. And that really is the best indicator that we have at this point. There is going to be another way that we can do it, but for now, this is going to be the closest we can get at this point to the instantaneous velocity at a time of 1 second. And that's